Sorry.
So in the decomposition of sodium chlorate, it focuses on how sodium chlorate decomposes by thermal decomposition. So obviously, always wear your safety goggles, gloves, since this experiment involves heat. Measure the masses to the 100th of a gram and record the data. Get a test tube and record the mass of the test tube. Put the test tube facing horizontally in a test tube clamp. Light the Bunsen burner. Gently move the test tube back and forth in the Bunsen burner. Remove the test tube immediately if a white flame is given off. Heat until there is no more bubbling or the material is solidified. And finally, wait until the test tube cools down and record the mass again to see the change in mass over the experiment.
That Bunsen
So,
burner looks like a dick.
Trial 1, the mass of the empty test tube was 3.34. Mass of the test tube in sodium chlorate was 119.78. Mass of the test tube in solid product is 58.44. In the appearance, the product was clear but firm. The product is solid and was produced from the heating of a gas. Stop.
It's dumb.
So, the initial mass of the sodium chlorate was heavier than the mass of the product, sodium chloride. The sodium chloride had a smaller mass. This is because the heating caused the mass to change. The sodium chloride decomposed, and not only was the sodium chloride, but oxygen was also given off. And so, we apologize. We put some pictures on this part that were not actually related to the lab. The zinc and hydrochloric acid lab, which lab setup is above for, is the zinc and hydrochloric acid. So we messed up the photos for the decomposing of sodium chlorate, and I had a drawing, which is of the lab setup, to add to the decomposition of sodium chlorate. Thank you.
All right, so first of all, disclaimer, this picture and this picture is on this one. The sodium bicarbonate and hydrochloric acid. So double replacement reactions, also called double displacement reactions, occur when parts of two ionic compounds are exchanged, making two new compounds. There are three main types of double displacement reactions: precipitation reaction, neutralization reaction, and gas formation. A precipitation reaction is when two aqueous ionic compounds form a new ionic compound that is either slightly soluble or not soluble in water. A neutralization reaction is an acid-base reaction which yields a solution with a neutral pH. A gas formation reaction is one which yields solely a gas product. During this lab, if successful, we should see a neutralization reaction, as we will be using an acid base of hydrochloric acid that will produce a neutral pH substance of sodium chloride. So, the objective or research question we're trying to answer is what changes will occur that it proves the double displacement happens. Our hypothesis is as follows. If the double replacement occurs, then there will be a release of gas or permanent change in the color of the substance. The independent variable is the hydrochloric acid, and the dependent variable is the white sodium hydrogen carbonate. The controlled variable is the white sodium hydrogen carbonate. Some materials you'll need are white sodium hydrogen carbonate, hydrochloric acid, 2 test tubes, and a crucible. Safety notes, basically, always just wear goggles and gloves, you know. Be careful not to bring the active reaction or non-active reaction close enough to make any contact with you or any other individual. Exposure to large amounts of white sodium hydrogen carbonate may result in some adverse health effects such as coughing and sneezing if a high concentration of dust has been inhaled. In addition, oral consumption of hydrochloric acid can lead to various serious health effects such as corrosion of the mucous membranes, esophagus, and stomach with nausea, vomiting, and diarrhea. Contact to skin produces severe burns, ulceration, and scarring. Therefore, make sure you are wearing the proper safety gear. Procedure. In one test tube, take a relatively small amount of white sodium hydrogen carbonate. In another test tube, pour a small amount of hydrochloric acid. Add all of the acid into the hydrogen carbonate. Observe the rapid reaction. Our data table. The first photo from the experiment shown is the white sodium hydrogen carbonate. That. that. The second photo shown is the reaction that occurs immediately upon adding the hydrochloric acid. The final photo shown below shows the result of the reaction. Data processing. The chemical reaction for the change, or the data, is constructed in the following way. First, the initial metal hydrogen carbonate translates to NaHCO3 salt. This is the white sodium hydrogen carbonate. Next, the acid will be added into this initial substance as HCl. This is hydrochloric acid. We are able to observe that during the reaction there is a release of carbon dioxide, water, and an ultimate result of sodium chloride, which all translate to CO2 gas plus H2O NaCl aqueous. So your final equation looks like this: NaHCO3S HCl CO2 goes to Cl2 gas plus H2OI plus liquid plus NaCl aqueous. In conclusion, the observations made that prove the displacement change occurred were two main observations. Firstly, there was a permanent change in color in the substance as the initial substance was white and the final solution was colorless. Secondly, during the immediate reaction...
I swear to God, I swear to God. Okay, so my lab is the dehydration of ethanol, and we predict that our research question actually is how does heat impact the dehydration of ethanol? We predict that the heat will cause the ethanol to give off a gas, but it doesn't. It really gives off an odor. And the independent variable is the heat, and the dependent is the amount of ethanol. Some safety notes: always wear goggles, because you don't want to get in your eyes. Wear gloves, so that you protect your hands, and don't get too close to the flame or anything, because that's just not good. Our procedure is first gather all materials for the lab, then put the test tube in the clamp at a 180-degree angle, and then after that, you get your bucket and you put water in it. You put another big test tube in it, and you put a little cord, rubber tube, from one test tube to the other test tube, and then after that you form your lab and put the material and then you clean up and dispose of everything properly, because you can't leave materials there. And then in conclusion, during this lab we heated ethanol and saw what kind of reaction would happen. What happened was that at first it was coming out as a gas that was being collected into the test tube that was upside down in the water, but over time the ethanol gave off an odor and eventually turned into ethylene. The chemical equation for the lab was C2H5OH, and the chemical equation after the lab was C2H2. And then right here are two pictures of the lab, and the first one is the lab setup, how it looks. So it's this shows the lab setup used when conducting the dehydration of ethanol. The water displacement method is used to be able to see the amount of ethylene collected at the top of one it was produced. This is done by placing ethanol in Okay, so this lab is the decomposition of baking soda, and basically you put baking soda in a test tube, put it over a Bunsen burner, and you let it on fire, and you see how much of the mass was lost in your experiment. So our hypothesis is that when the solution is heated up, it will create a chemical reaction with the baking powder and water, in which water creates bubbles and moves around. The independent variables are the amount of water during the experiment, the container, and the level of heat. The dependent variable is the amount of baking soda. So some safety things are always wear goggles, gloves, and don't go too close to fire or anything. So our procedure is one, you have to set up the lab, and you get a bucket, put water in it, put a big test tube, get a clamp, put a small test tube, put a tube into each, and then you put the Bunsen burner under the tiny test tube. Then you measure your baking soda, and at first you start with 1.6 grams, and then you put it in the test tube, and then you start your lab. After you should have 1.08 grams of baking soda left, And then, so you weigh it, and then after that, you clean up your area to make sure everything's good and like clean. And then in conclusion, we use the reaction of baking powder to heat and observe chemical reaction in the water displacement method. We use many materials and wear gloves and goggles to protect ourselves. And in the end, we saw the effect of baking powder on water when heated up. And then right here, we have a picture. And this picture is, this is the plate you put the baking powder and baking soda on to weigh it. And it says, during this, we weighed 1.6 grams of baking soda to see how much baking soda is lost.